one more frequently asked question from the portion VBT. Explain the geometry and magnetic behavior of FeF6 3-. So the given coordination compound is FeF6 3-. We have to find out its geometry and its magnetic behavior. So first thing, as we have already explained in the previous sessions, to know the central metal atom or ion, that is Fe here. Fe is having the atomic number 26. So it will have the outer electronic configuration 3d6 4s2. 3d6 4s2. That we have arranged according to Hund's rule of maximum multiplicity. And then the next step is to know the oxidation state of the central metal ion or atom. So Fe is in plus 3 oxidation state here. So this is 6 minus, and so Fe is in 3 plus oxidation state. So what is the outer electronic configuration of Fe3 plus ion? Fe3 plus ion will lose 2 electron plus 2 electron from this 4s orbital and then 1 electron from this 3d orbital. So we will have 3d5, its outer electronic configuration. 4s and 4p orbitals will be empty. And then next step is the formation of FeF6 3- complex. During the formation of that complex, this first 3d orbital is having 5 electrons. 1, 2, 3, 4, 5. And to that metal ion, F- ligands are approaching. According to weak field ligands or strong field ligands, when we look in that order, we can see F- is a weak field ligand. That means it will not have the ability to push and make these electrons, these unpaired electrons in 3d orbitals to get paired. For them, it has no strength to make these unpaired electrons to get paired up. So what they will do? They will take the place of the empty orbitals available in the metal ion. So we can see the coming ligands. Each F- ligand will donate one pair of electrons, a pair of electrons. So F1, F- ion, there are 6 F- ligands are there, 6 F- ligands are there. So one will give one pair of electron, and then the next one 3, 4, this is the 4th pair. Still 2 more pairs are there. So we will consider the outer 4d orbital of metal ion 2. So this is the 4d orbital of metal ion. So this next 2 pairs will occupy here. So 1, 2, 3, 4, 5, 6. 6 pairs of F- ligands occupied in the vacant orbitals of central metal ion. So it's by knowing this we can predict its geometry. That is the first question. Explain the geometry. So hybridization is happened. Hybrid orbitals are formed by using these orbitals of central metal ion. So this hybridization is taken place by 1 s orbital, 3 p orbitals, sp3, 1, 2, 3, and 2 d orbitals. 2 d orbitals of central ion. So its hybridization is sp3d2. So if hybridization is Fp3d2, its geometry will be, what will be the shape of that particular complex? It will be having octahedral geometry. It will be having octahedral geometry. And then looking into the magnetic behavior, we can say this is paramagnetic, strongly paramagnetic, because many number of unpaired electrons are present in the given complex. So it is paramagnetic in nature. It's paramagnetic in nature, and then it is an outer orbital complex because the orbitals involved is ns, np, nd. So ns, np, nd, that is 4s, 4p, 4d orbitals are involved in hybridization. That means it is an outer orbital complex or high spin complex. Outer orbital complex or high spin complex. So this is the answer for the given question. If you can answer all this by giving all these points, you will get full mark for the given question, and it is clear for you, I hope. So this is the end of our session today. See you again.